Hello and welcome. This is James from the DSO Imager channel. Today I'm going to show you the processing that I used for this shot of M77. Now this video is going to be a little different than my typical workflow videos in that I'm actually going to show some detailed steps on how I corrected some issues. Now the shot that you see here is a 16-hour shot of M77, and this was the picture that I was going to run with. The weather had turned and I decided that it was a good time to end this project and move on to something else. But a funny thing happened. After a couple of days of poor weather, things cleared up again, and I decided I wanted to get more data on this target, mostly because these outer bands are very faint, and it looked like I was just starting to get some detail in there, so I wanted to see if I could get more. As usual, I'm always after more. And so I got more data than this. I believe I'm up to 26, 28 hours, something like that. I'm pushing 30 hours. But there is a problem that I ran into. And because I thought that I was going to be finished with this target, I actually took the imaging train down and cleaned the corrector plate on the front and did a few other things and put everything back together, and the rotation of the camera changed. Now the ASI 533 MC, which is the camera that I'm using on this, is a square sensor, and so camera rotation is not too critical, but if you're trying to put together multiple sessions, it can present an issue. So let me show you what I ended up with here as far as raw collected data. Alright, so can you see the issue here? Yeah, you can see the rotation in the corners. I wasn't sure how far off I was going to be before I started taking these pictures, and I thought if it wasn't too far off it wouldn't matter, but clearly it matters, and this little galaxy here is at risk. But the nice thing about galaxy shots is that other than the stars, there's really nothing of consequence in these messed up corners. I really liked the field of view with the original framing, mostly because I squeezed that galaxy in there. And so what I wanted to do is blend these two together without cropping and tightening the field of view here. Alright, so first I need to integrate the stacked images. I have 4 separate stacks, so I broke the capture of this data into 4 parts. So we'll go to integration. You can see they're already populated in here. It's just hit add files and use your Windows browser. Now I already registered everything. This P1, this is the original, the first 16 hours. And then I grabbed 3 more chunks. They're already registered. You can see it says registered. And so now I'm going to integrate all of this together. Alright, there we go. So you see we get a rejection mask. This mask potentially is handy. And I thought I might use this mask to kind of correct for these areas, but I ended up using clone stamp instead. Alright, so let's put this aside over here. Here we go. So very first step that I do now with the latest version of Blur Exterminator out there is I do a correction. Here it is. So we do this correct only, and what the correct only does is it corrects the star shapes in the corners, and more importantly, especially for this setup, is it helps align the colors. See the color separation here? It helps. It doesn't completely solve this, but it helps a lot. So we'll hit this with a quick correction here. Alright, let's take a look. See how much better that looks? I mean, you can still see a little bit of the separation there. It's fixed the shapes too. So that did nice. Alright, next up is dynamic background extraction. And actually, to do dynamic background extraction, what we first want to do is make a copy. So I'll put this up here. And we want to remove the stars. So we'll use Star Exterminator. We're not going to save this star image. We just want to remove those stars. I'll go ahead and stop the recording and start it up after Star Exterminator is finished. Okay, Star Exterminator complete. That actually didn't take long. I probably didn't need to stop the recording. But let's get dynamic background extraction. These are the values I typically use. They work pretty well most of the time. Sample size, just a medium size. Then I'm going to hit generate. Now, what I don't want to include, and this is my own thinking, it's just me thinking about this, so maybe I'm wrong with some of these steps, but my thoughts are I don't want these impacted areas to be included in the calculation of the background. So I'm just going to eliminate the reference points that are in the corners here. Also, what I'm finding is that when removing the stars, let me back up a second. So the thing is, with removing the stars, you can then run a model of dynamic background extraction against the starless image, save the process, and then go back to your original image with the stars in place and just run that saved process against it. And it's not going to be impacted by all the stars in the original image. So it's easier and faster to do it this way, instead of having to inspect each reference point and move it around to try and get it in between the stars, and especially in fields where the star field's very full, it's hard to find empty spaces for these reference points. So anyway, that's what I'm doing here. And I also find that I get better results if I don't, oops, I didn't want to delete that one, but not use reference points in these areas where there was a bright star, and so you have like some background here, this artifact. We don't want to sample this either. Alright. Now, what's interesting on this target is that the additional time I captured, it did not really resolve these faint dust bands very well. Like, I probably need an insane amount of collection or really darker skies, I think, to get more out of here. But what it did pick up was some more really faint starlight from this galaxy around here. So I don't want the reference points to be in any of this either. Reference pictures that I've looked at of this target does show this on some of the deeper images of it. So I mean, this is all legit light coming from the galaxy. So I don't want to sample any of that as background data either. So this is what I got. I always save the process. That way, if I have to go back and make modifications to it, I can. And then I use division, discard, and then save it. And then run that. And what do we get? Yeah, I think that's pretty good. Now that we've worked out a good setting for our dynamic background extraction, we can put that aside, and we can now apply dynamic background extraction to the main image that we're working on. And so even though, notice how you got the reference point here, even it's showing a star, it's not gonna, this is not gonna impact the value because we got these this reading from the starless image. So there we go. Alright, next we're going to do color calibration. There's a couple of different ways to do it, but what I'm going to do is use I always have trouble remembering the wording here, spectrophotometric color calibration. It's a bit of a mouthful. But anyway, to make that work, we first need to solve this image. So it is M77. It doesn't really matter which one you pick. There we got a date in there. That's not, it's good enough. If this image solver ever doesn't work, make sure you have either the resolution or the focal distance accurate along with pixel size, because that's usually what's going to cause problems for it. So this will just take a moment here. Alright, now we can do the color calibration. We do want a background reference, so we just draw a reference box on an empty area. Region of interest from preview, we select the preview. For ideal curve, since this is a 533, I can select the 533. And this just takes a moment. There we go. And now with the screen transfer function, I can now do a locked auto stretch, and there. Now we're getting mostly balanced colors. I still think the color is not perfect, but it's okay. Now with color calibration finished, we can go back to Blur Exterminator. Let me just kill that preview box. And now with Blur Exterminator, we can use the actual deconvolution techniques or function. Now, what I sometimes do, especially on these galaxies, is to kind of dial in the settings. So I'm going to use automatic PSF. Now it's hard to tell what it's going to do in the galaxy because it's so bright. This is such a bright target. So I'm going to pull this back. Wow, look how bright that center is. Just so that we can get an idea of what Blur Exterminator is going to do for us. So I'm going to leave it on these settings that I have here. It should go pretty quick since this is a small preview box. There we go. And yeah, that did a pretty good job. So I'm going to stick with these settings, and I'll just apply it to the whole image. And I will pause the recording and I'll be back after it's finished. Okay, Blur Exterminator is finished. And yeah, this looks pretty good. Like I was saying, I still didn't get the level of detail I wanted in these outer bands. I mean, we can see a little bit more clear, pretty well, I won't call it clear, but we got a dark dust lane here, and you can see maybe a little bit better. Not a whole lot of difference between this and the 16-hour shot. So yeah, I think I'll need a lot more time to pick to better resolve this. Anyway, let's see. Next step is to remove the stars. Delete the preview and Star Exterminator. This time we want to save the stars. Alright, let's put the stars over here. Let's auto stretch this again. Alright, so now we're going to clean this up here. So I'm going to use clone stamp. And I mean, this works because it's a galaxy in a relatively empty field, so we're not really messing with anything. I'm also going to knock out these artifacts left over from the bright stars. There we go. Now, when I use clone stamp, I find that it works. I get better results if I kind of randomize where I'm getting the reference point. If you just hit one and then you just kind of go along the line, you actually create more artifacts. It's kind of interesting. Oops. There we go. See that pattern? You got a little bit of a pattern here because I didn't randomize the reference point enough. Oops. All right, let's clean this up a little bit more. All right, I think that's pretty good. For this galaxy here, we need to make a mask to protect that. And in order to do that, I actually have to stretch this. Because if I try to make a game mask right now, it's going to look like this. I won't be able to make the mask. So let's do histogram. Oh yeah, if you see that, it's because clone stamp's open. I gotta actually close it. All right. All right, game mask, script, utilities, where are we at? Game. We'll zoom in. Add. That should do. Hit OK. There's our mask. Let's take this stretched one and get it out of the way. Make sure we're working on the unstretched one. Apply the mask. Invert the mask. And let's get clone stamp back up. Oh, let's hide the mask. There we go. All right, so yeah, that took care of it. So those corners are not a problem anymore, and I can proceed with stretching at this point. So yeah, this type of target, this type of circumstances, it allowed me to get away with the issue with the rotation, and yeah, it worked out. Now I'll start stretching this, and I may just show a brief workflow that I did going forward, but it's mostly going to be stretching with GHS and then a bunch of curves work mostly. So let's see how it turns out. Now I have finished processing this image, so I'll just show you the rest of the processing workflow really quick. Now, one thing that I needed to work on, or what I did, is I split the luminance from the color. And the reason I did that, here's a 16-hour shot. Oh, by the way, this latest version is 24 hours. That's how much time I added. But here's a 16-hour shot, and if you get in closer, you see kind of like this mottled look of the color. I get this occasionally with these one-shot color images, and I'm not entirely sure what causes it, but it does happen more often with one-shot color than mono. It could be that I was just pushing the data too much. Maybe it's too faint. But one way to kind of avoid this is to split the luminance from the color data and process them separately, really kind of like processing mono images. And to extract the luminance, I just hit this button over here, right there. Alright, so here's the luminance, and I use GHS to stretch, and we'll see how that comes out. Yeah, so that was after the initial stretch, which is pretty good. But man, these outer bands are so faint that it was difficult to pull them out. So here I'm putting a mask on, and the idea is to protect the core, because the core is insanely bright on this galaxy compared to these bands. And let's hide the mask and apply some more stretching. Yeah, see? So I'm trying to pull out these background, and all this stuff over here, this is all light coming from the galaxy, so you don't usually see this. Yeah, I can just barely pick out some of the details in there. So after that, it was pretty much the same deal on the color. Now the other thing that I've noticed about this particular target, there really isn't a lot of color, which is interesting. I had trouble getting color out of this. Alright, so I mean we can see some color, but it's very muted, and it's not consistent. Just different stages of stretching this and getting it ready to add. So here you can see how smooth this is. So the thing with mono processing, and it works here when you do it with one-shot color, is that we don't need any detail in the color image. Right? You see, I really pushed the color. Look at this color noise. So I used noise exterminator with no detail enhancements, just 100% denoise. That smoothed it all out. And then we add the luminance to it, and we end up with this. Yeah, so before the luminance, with the luminance. I ended up taking this into Photoshop to use mostly the camera raw filter, and ended up with this here. So got a little bit more color out of it. I mean, it's still, I'm not overall happy with the way all this looks here. And then it was pretty much working on the stars after that, I believe. Let's see. This is more luminance. Yeah, okay, this is the final starless image I ended up with. And then with the stars, I went through a couple iterations, right? So this is with minimal stars. And I felt like it was too empty here. I wanted the stars to be more... I wanted more stars in here, but I didn't want these, like this one here, some of these brighter ones to get too bright. So what I ended up doing is... Let's see. Yeah, you can see a difference in the stars here. All I did is I just made a mask. Let's see. Where is it? I'll probably have trouble finding the mask now. But anyway, I made a mask and I protected these larger stars and then just stretched more to pull out some of these smaller itty-bitty stars here. And when I did that, I liked the results, except I wasn't crazy about this halo here around this star, right? I mean, this star realistically should probably be bigger, but I didn't want it to pull away. That's kind of cool. So what you're seeing here on this image here is a mask. And I just dialed back that halo. And the final result is this here. There we go. And there's that halo. I just toned it down. It's still there. But it doesn't draw your eye away from the galaxy like it did before. Oh, and there's that little galaxy that I was trying to save earlier, right? So even got some color out of there, which is kind of cool. Got more color out of this one than I did in the primary target, it feels like. Alright, so there it is, M77. This turned out to be a far more challenging galaxy than I thought it would be when I started. And honestly, between the 16-hour version and the 24-hour version, did I need that extra time? Probably not. In some ways, I like the way this one looks better until I zoom in, then it kind of falls apart. But whatever. I think the main point of this video, more than the target itself on M77, was just to show how I handled mixing data from two different rotation sets. And I think people might find that interesting. So anyway, let me know in the comments what you think. Don't forget to like and subscribe, and clear skies.